Hello, welcome to the Math Vlog. This vlog is a second in a series. There'll be one more video after this. Our first vlog, we talked about how we can check our answers, our gut check, to see if it matches what we expect or not. Does it fit the question? Now we're going to go ahead and solve a word problem. And the type of word problem we're going to solve is going to have two equations with two unknowns. It's a system of equations. We're assuming you know how to solve equations with a graphing method, the substitution method, and the elimination method to solve a system of two equations with two unknowns. If you don't know how to do those three methods, go back to your previous vlogs in this series. Here's a situation. We're at a college basketball game. It could be here at Rochester Institute of Technology. It could be at a smaller college, no matter. The college game is attended by people, and there are 1,243 people to be exact at that game. Colleges send tickets to their games to support the programs, and usually students will have a reduced rate for ticket sales. On this problem, the students paid $2 for their tickets, and then non-students, meaning faculty members, parents, community members, general admission was $8. Okay, so we can picture this. We have students along with non-students, general admission people, at this basketball game. Now, to figure out how much money they collected, how do we figure that out? It's money they have earned, and we have here the total sales were $5,018 for ticket sales. Now, this is how much they earned from that game. Now we need to talk about, we're going to figure out how many students we have and how many non-students came to the game. In general, in word problems, we'll use or needs a five-step process to solve them. It helps us analyze what we need to do and how to do it. I'll be labeling them 1 through 5 as we go along. The first step would be to discover or figure out what the question is. What's the problem asking us to find out? I'm gonna label it in yellow, and you'll see it in a minute. Now, with the highlighting, we can see how many students and how many students have attended the game. That's our question. Now, our first step is done. Now on to our second step. Well, let's pause for a minute here. If you think about this, what are possible answers for how many students, how many non-students? Could we have a negative number of non-students or negative number of students? That's not possible. And we're talking about real people who are at the game. If we figure out the answer and get a negative answer, we should go back and check our work. Something's wrong. What else is not possible? You can't have half a person, so that's not possible. There are some more things that aren't possible, I think. Okay. We had 1,243 people in total at the game. And also, the number of students or non-students, it can't go over 1,243 because the total people in attendance was 1,243. So if I found 2,000 students to be there, something's wrong. Now, maybe all of the people that came were students. We had 1,243 students, or we had 1,243 non-students, and we had none of the other. That's possible. That's possible. Maybe the students stayed home that day for the game, in the dorm. But really, what we can't have are students or non-students that number more than 1,243. Now to our second step. Represent. What I'm meaning here is to pick a variable that represents your unknowns. You can use X and Y, but I tend to use letters that relate to the problem. I'm not going to be all creative here. I'm going to use S for students and N for non-students. Pretty simple. Okay. Now the third step, in my opinion, I believe is the hardest part of this whole process. We need to translate what we know, what we see in our problem into two equations. We need two equations with two unknowns. Well, we know that the number of students plus the number of non-students equals 1,243. So we could say S plus N equals 1,243. All right. Now, we need a second equation. It's a general rule: two unknowns, two equations; three unknowns, three equations. That's how you can solve for those unknowns. If we have one unknown, one equation, and so on and so forth. So, what else do we know? Well, so the money. We know how much money they earned that night. The total collected ticket sales. Now, how can we figure these out with the students and the non-students? Well, each ticket that a student purchased cost $2. So all the students, if I times the number of students times 2, I would know how much money the students gave or spent in the game. Now, how about for general admission? They cost $8. So it'd be 8 times the number of non-students would equal all the ticket sales from non-student people. Now, our total sales should be $5,018. Now I say earned, but it's collected they collected $5,018 from their ticket sales that evening at that game. Okay. Now we have two equations and two unknowns. Now we have three methods to choose from. We could use a graphing method, substitution method, or elimination method, but really, in this kind of problem, most often I use the substitution method. You can see here the s variable and the n variable, s plus n, neither one of them have coefficients, so it would be easy to solve for either one of those and isolate the s or the n. I'm going to solve for s, or isolate for s first. Okay, now this s we're going to substitute in the other equation where the s variable is. So now, as you can see, after I substitute in for the s, I have one variable, n, and you see it here twice, and one equation. I can solve for n now. And I'll go through and solve for n right now. Now you can see I combined negative n and positive 8n and got positive 6n. Now I'm going to subtract 2,486 from both sides. I figured that out earlier. Okay, good. Here it is. So we've already figured the n. Now n is equal to 422. Now n. Well, oh yes, n are the non-students. Okay, out of our total attendance, we had 422 non-students. Does it make sense? Yeah, it's between 0 and 1243. So 0 to 1,243. This is right in the middle there. It's not a negative number. It's not over our total amount. It seems reasonable. Now, understand, we're not finished yet. We have to find s. We have to calculate s. We have to go back to the equations we created, substitute 422 in for n, and solve for s. we have S plus N equals 1243. Now we're going to solve for S. I know what N is, 422. I need to know how many students came to the game now. Okay, so now we have S. N equals 422, and S equals 821. They make sense. If I were to add them together, it would get to 1243. Now, it's not guaranteed, but I have to go back and do my check. I have to check in both equations. Let's do it now. So now, 2S plus 8N equals 5,018. We need this equation plus the other one, S plus N equals 1243, to check our answers. Now, this will equal 5,018. You can go ahead and multiply and add them together, and it will come out to be true. Thanks for watching this vlog.